Here's a problem where we have a series of questions where we're given a statement in words and we are to translate that into a symbolic form and lastly calculate the result. To give you a summary before we start, if ever you have a number, say A, decreased by another number B, you would write that is A subtract B. A is decreased and B is how much it's decreased. A decreased by B. Or you could read this as A minus B. Now the words over here actually has you switching the order of subtraction. So notice even though A is on the left of the sentence, it actually is on the right of the subtraction statement. So when you read A less than B, that means you want to take the number B and you want to make it smaller, meaning you want it less than what it is. So how much less do you want B to be? You want A less than B. So this represents the number B and you're taking A less than that. Finally, we have A subtracted from B. So here you have to be careful. This representation over here could be read A subtract B, meaning you're subtracting B, but this statement is the reverse of that. It says A is being subtracted from B, meaning we have the number B and A is being subtracted from it. So it's the A that's being subtracted. So this can get confusing, so I want to do a few examples. In the first example, we have -7 minus -5. So that would be this case, because they use the word minus. A minus B means to write the A first, then the B. So -7 minus -5 would be written the number -7, and then minus means to write a minus symbol, and then the number -5. To calculate the result, one way to do this is to leave the -7 as it is, change the subtraction to addition problem. I changed the subtraction or the minus symbol to an addition, but then you also must change the sign on the second number. So this would change to a +5 because it's currently a -5. Then the rule to add numbers with opposite signs is to take their absolute value. That would be 7 and 5. Then you take the larger of the two results that you got after taking the absolute value. That would be 7. And then you take away the 5. So then taking the larger absolute value and subtracting the smaller absolute value, you'd get 2. So the answer is 2. But the rule is at the end to keep the sign that was in front of the number that had the larger absolute value. Here are the two absolute values, and 7 was the larger of 2. The sign on the 7 was negative, so my final answer will have a negative. So the calculated result would be -2. Let's do another example. In this statement, we have -9 subtracted from 5. So what we want is the second case. If A is being subtracted from B, it means the second number in the statement actually goes first. So that's the word 5, so I'm going to write 5. And we want to subtract something from 5. In fact, we want -9 to be subtracted from 5. So it's the -9 that's being subtracted off of the 5. So we have the 5, and we are to subtract off. And what are we to subtract off? The number -9. Let me write the number -9 in parentheses. So here we have the number -9 being subtracted from the number 5. To calculate the result, one way to do this is to change the subtraction into addition. So I'm going to leave the sign on the 5. So you could think of this as a +5. We're going to leave it as 5. And then I'm going to change the subtraction to addition. And then if you do that, you have to change the sign on the second number. My second number was -9. I'm going to change it to +9. And now I don't need parentheses. If you'd like, you can use parentheses. It wouldn't make a difference. And then 9 and 5 added together would simply be 14. I'd like to do 2 or 3 more examples. Here's an example where it says 9 decreased by -5. So they're using the words decreased by. So they're using the word decreased by. Whenever you have a sentence such as something decreased by something else, say A decreased by B, the order goes in line with the sentence. A is at the beginning of the sentence, and it'll be first in the mathematical statement. B is at the end of the sentence, and it'll be at the end of the mathematical statement. So A decreased by B means you have the number A, you're going to decrease it, and you're going to decrease it by this amount. So we have the number 9, and we are to decrease it, so that would be minus. How much are we to decrease the number 9 by? Well, the number -5. So I will put that in parentheses, -5. And one way to calculate this result is to change the subtraction into addition. And if you change the operation from subtraction to addition, you must change the sign on the second number. It's a -5, so I'm going to change it to a +5. And 9 and 5 added together simply make 14. Here's a problem where we want 7 subtracted from -5. Whenever you see the word subtracted from, it's of the case that the order of the numbers in the word statement is reversed relative to the symbolic representation. So notice that the A comes at the beginning of the word statement, but at the end of the symbolic representation. And the number at the end of the statement, being -5 here, ends up at the beginning of the symbolic representation. So the -5 at the end of the statement will be written first, -5, in my symbolic representation. And to make sense of this, we don't want 7 subtract -5. We want the 7 to be subtracted from the -5. So you may write it this way. So you may think of it as, here's the number 7, and it's being subtracted from the number -5. And to calculate the result, one way to do this is to go back to the chip model. It's like you have 5 negative chips, 1, 2, 3, 4, 5, and we are to take away 7 positive chips. But there are no positive chips for which to take 7 away from. So one thing you can do is add several zeros, if you will. A zero can be thought of as a negative-positive pair. Because a negative and a positive cancel out to be 0, adding it to the problem doesn't change the value of the expression. So doing this did not change the value of my answer, but at least gave me a positive chip to work with. But eventually I'm going to need 7 positive chips so that I can take them away. So I'm going to add 7 of these pairs. So here's 1, 2, 3, 4, 5, 6, 7 of these pairs, which can be thought of as adding 0, since a negative chip and a positive chip sum to 0. Now that I have my 5 negative chips here, and I'm going to take away 7 of the positive chips, here's 4 of the positive chips, here's 3 more of the positive chips. If you counted them, there's 7 positive chips. If I was to subtract them or take them away, what would be left would be my answer. Obviously my answer would be negative because there's nothing left but negative chips. Now it's just a matter of figuring out how many there are. There's the original 5, 1, 2, 3, 4, 5, and I'm supposed to add on the rest, 6, 7, 8, 9, 10, 11, 12. So I end up with 12 negative chips, so the calculated result would be -12. I'd like to do one last example. Here we have 5 less than -9. So this is one of those cases, since they use the word less than, that the order in which the numbers appear in the statement will be reversed relative to that in the symbolic representation. Meaning that the number at the end of the sentence, for example, -9, that would be this, even though it's at the end of the word statement, it'll actually be at the beginning of the symbolic representation. So I'm actually going to start with the number -9. We want our final result to be less than that, so we're going to take away some. How much we want our final answer less than -9 is right here. We want our final answer to be 5 less than the number -9. Then to calculate the result, one thing you could do is go to the chip model and say that you start with 9 negative chips. So here's 9 negative chips, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are to take away 5 positive chips. And if you look, I don't have any positive chips for which to take them away. So what I can do is I can introduce a positive-negative pair. And because a positive chip and a negative chip cancel out, or you could think of as a positive 1 and a negative 1 summed to 0, adding this pair doesn't change the value of my problem. Putting a plus and a minus here, if they were to cancel, I'd still be left with my 9 negative chips. So doing so introduced a positive chip for which I could take away, but in the end I need to take away 5 positive chips, so I'm going to have to introduce 5 of these pairs. So here I have 1, 2, 3, 4, 5 of these positive negative pairs. Now that I've done that and I haven't changed the value of my problem, I have 5 positive chips for which I can subtract. So 1, 2, 3, 4, 5, here's my 5 positive chips, and I am to subtract them from the problem. Once I take them away from the problem, what's left is several negative chips. Here's the original 9 negative chips, and I just need to count out how many there are total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 chips, but since they're negative, that means that the result is negative 14.